we are here to talk about front-end web development. So I would like to spend a few words about what to me is front-end. These two guys here are to me the first front-enders ever. They are trying to use the output of a computer. It's what we do. We are trying to produce output so people can understand it. Okay, that's when things began. I'm Marco. I work in Copenhagen at Citrix. We do mobile applications. I am a front-end developer. I love Java. I love open source. That's why we do that. So then, this is me in the 70s. Okay, it's me working as a front-ender with a really new machine, last model ever, black screen, green characters. Here it was like a few years before it was buttons. Okay, even in these years, in few time, things had evolved from buttons to a screen. Computers in this era were really complicated machine. Really complicated. A guy here should be a doctor or something like that. He doesn't understand what's going on in this stuff. But really quickly, computers has gotten smaller. They started to fit our desks. They started to give us more compact ways to deal with computers, and we got into this business of developing applications that many people could use. In a few more years, computers had become portable objects. We all know laptops are quite old stuff so far, but tablets and mobile phones are really recent devices that 20 years ago we couldn't even think about that. Computers had become wearables. This was announced a few weeks ago, 1 or 2 weeks ago. And we still don't know if it's going to change our lives, as Tim Cook is suggesting, but still is something that wasn't in our lives 10 years ago. I could never have thought to put my hands on a device like that when I began to be a front-ender. Okay? And now in a few months I will code applications and interfaces for this object. That's evolution of computers. And computers are the objects that we use to produce output, to produce front-end images eventually. So, also we are front-enders on a web. So, what about web pages? Sorry. Okay. Okay. Later I explain this stuff. What about the web pages? How they had evolved in time? Well, I've started to deal with web pages in the all kind of problems. Are we good? Yes. I've started to deal with web pages in the 98, early 2000. I started to work, and basically I was doing under construction pages. Everything was just an under construction page, and it's not visible here, but those pages were optimized for Internet Explorer 5. I mean, the last possible technology in the browser business. I was dealing with specific screen resolution. I was architecting my interface for 800 and 600, stuff like that. Okay, pages in this era were made of links. Okay, this is eBay. Few years ago, it was all about links, resources. That was what internet was meant for, what a web page was meant for, connecting resources, giving the possibility to go from A to B with a click, connecting pages. I don't know about you, but I remember how much we used tables to lay out our pages. Everything was just a box, a column, and nesting tables, and Dreamweaver everywhere to just make a sense of all of it. And of course, rounded borders. They were a big deal 5 years ago. Okay, today is a CSS properties, but guys, to do that in 2004, you were a pro. So then even web pages had changed in time to become, responsive. Today we talk only about responsive design. Everything you conceive, everything you produce has to work on all the browsers, all the computers, all the resolution, mobile phones, and whatever, the watch tomorrow. It will be a request to put here. Okay. What about JavaScript? JavaScript is a programming language. It's what brings life to a web page. So web page is a presentation layer, and JavaScript allows to do something more. Well, again, when I started, I used JavaScript to do simple things like confirm, alert, prompt. That was user interaction. Okay, cancel, no more than that. Okay, then a little company came into the picture in 1st April 2004, Gmail born. Gmail had been the first web application that was using the HTML platform plus JavaScript to behave like a proper application. So to change stuff before your eyes without refreshing the page, to change views. Okay, this application made us developers, as community, trust more about the web as a platform to build real stuff, not only web pages, not only presenting data that I write and you have to read, but a proper process that you can consume and that you can interact with. This has led to what is JavaScript today. So a big amount of frameworks and companies that produce open source frameworks. Citrix is producing its own open source framework. Everybody is. Why is that? Because everybody has its own understanding of how things should work on a client. Because JavaScript is so free, is so open that there is no structure for people that comes from the Java world. They always ask me, oh, JavaScript is a mess. JavaScript is like the Far West. Yes, it is. It is because we are just starting to find our way toward an organization, toward a kind of order to work better with it. Backbone, Angular, React are big names in this business of giving order to a language that was born because a guy decided to add a feature in a browser in a couple of days. Okay, it wasn't a big enterprise language that was produced by IBM or something like that. It was something that had born from us, from the community, to be in the browser. Today we talk about React, which is just one of the names in this slide. It's not even the bigger yet. It has some points to become, but it's still not the bigger. Okay, so then what is the bottom line of this evolution thing that I placed here? Is that everything changes in time. It can take years, it can take months, but everything changes. What we learn today, it will not be useful as absolute knowledge tomorrow. So what we learn today should be used only as a tool to take better decisions tomorrow. Okay. So even if tonight we talk about React and we will see some code and stuff like that, I really beg you to do not consider React just, oh, there is only this one. It's the one that is coming out today. That we already know that in a few years, something else, maybe one of us will create the next thing. Okay, that's what we will do here at this Frontbox events. We will talk about the HTML environment, the HTML community, but I would like to have you come here and talk about what you do, how you use these tools, and what you think is good to use in your daily job activity with a mind open to change. It will be Frontbox. Okay, that was the introduction. So, we move to React. How many here are developers? Great. JavaScript developers. Java developers? That's the door. Okay. ReactJS is a a JavaScript framework for creating applications, web applications, is driven by Facebook, by the guys that are behind the Facebook advertising branch. And why they build it? They build it for performances, rendering performances. We come right now from 2 years in which AngularJS had spread bigger with the two-way bindings approach that ties a template with some data in a view model and keep them in sync in 2 ways. So data can update the template, and the template can fetch user interaction and put it into data. React comes with a completely different approach. It comes with a one-way rendering direction, because in a way, it takes back what COBOL programmers did when they were coding the arcade games, in which you have a bunch of data that represent where the character is, where the weapons are, what the weapons are doing, and it translates this data into a picture, into a couple of pixels. React does that because it's quick. It's that quick compared to the two-way bindings. And what they needed in their application, which is quite complex compared to the normal application, they need only rendering speed. They didn't need anything else. That's why they did it. So, what is React? React is, of course, a UI library. So, the point of React is to take some data and to produce something that is visible. Later on, we will see that the something that React produces, or that we produce with React, is a description of how our interface should be. Okay? But for now, we just consider that UI means take data, what the application knows in a given moment, and we transform with a machine this data into a description of what the user should see on a screen. Okay. Okay, we are already talk about the one way. So this transformation is monodirectional. Of course, we take also in consideration the user activity, so the events, but they follow a different path. We'll see it later. React is made for fast rendering. We did it. And another important, really important point of React is build from the very beginning to create isomorphic applications. How many of you knows what an isomorphic application is? Good. For the others, an isomorphic application is a modern web application built on JavaScript that can be rendered on the server. I want to spend a few words about this concept, because it will be the future of web development, or at least the next future. For the next few years, we will do this. We will work with isomorphic applications. Web 2.0, it was creating dynamic pages in the backend, so the user can see some customized information on the client and can interact with some customized pages. Okay, that was the realm of the GSP, of Ruby on Rails frameworks that on the server were producing custom pages, were producing custom HTML made from a template plus some data coupled together and packed to the client. Okay, a modern web application, what we are doing since 2 years, comes as a JavaScript bundle, probably. So you have a huge amount of JavaScript made in Angular, Backbone, Ember, or whatever you use today, and a process that couple these files together in order to produce an application. Okay, so in the browser, you receive an empty web page, a big ass bundle of JavaScript that on the client produce the HTML that the browser will show. Okay, that's server-side rendered application and client-side rendered application. What's the drawback of client-side rendering? Google. That's basically the only drawback if we don't consider a little bit of loading speed. But Google is the big drawback. How many of you knows who Airbnb is? it's quite famous. Okay, it's for the others. Airbnb is a service in which you can book a room in a house that somebody like us sell on one-to-one exchange basis, something like that. So it's not a hotel stuff. It's a room in a house. Okay, that's not that the point. Those guys are building their website, which is a really, really big and high traffic website. They were building it with server-side rendering. They moved to a client-side rendering because it's a faster development process and you can do more interesting things. But they basically hit the wall because, why? Because they lose a lot of indexation in Google. They lose. Basically, their website became invisible to Google. There was only one single index HTML page with an empty body and a single line of a single script that were requiring the full application. Okay, a little bit more complicated than that, but that's the bottom line. Okay, and they said, oh, we can't do that. We need all our announcement or all our pages to be visible to Google. And they started to build a sidetrack website that were producing server-side those pages, but when these pages were loaded by a browser, they were redirecting back to the real application. That's craziness. So they said, why the heck can't we render our application on the server, ship the pre-rendered application to the browser, and on the browser just continue to use the application, to make the application to work. Okay, eventually an application on a browser is a bunch of HTML and event handlers that listen what the user is doing and bubble up events to the application. So that's isomorphic. Okay, it's rendering the application on the server, so your HTML comes down to the client shipped with the first bunch of HTML that represent the initial visual state of the application, and just you drop in the event handlers. That's it. Frameworks like Angular or Knockout or Ember are working hard like hell to get to this point, but it's way, way difficult to just apply the handlers over an existing HTML structure with the two-way bindings application. With React comes extremely easier. Later on we'll see a demo about that. So that's the future, seriously. Interesting part. What React isn't? That's another interesting question, because if you go to Stack Overflow and read about React, you find a huge amount of questions that are not really, really to the point. It's important to know what the tool is not meant for when you start using it, so you don't mistake with it. So, first, React is not a library. Come on, okay? React is not a library that helps you to write less code. jQuery was meant for that. jQuery is an incredible, mighty library that gives you a shortcut for do stuff. Okay, I have to. My profession is thanks to jQuery that show me the way a few years ago. But React is different. It's meant for performance and is meant for code organization and for building an enterprise application across a big team. Okay, it's not for writing less code. So if you search for writing less code, don't use React. It's not a do-everything library. We have Angular for that, or Meteor. Okay, React takes care only of the visual part of the application. It's the machine that takes data and produces something on the screen. No more than that. Where data comes from, it's your business. How you deal with data, how you deal with routing, how you deal with caching is not React business. It's not that React doesn't provide you any tool. It's just not React business. Okay, you can couple React with whatever other tool you want for maintaining the business layer of your application. That's another important thing. React is also not a templating system. So basically but for Backbone, all the frameworks that I've seen in my career path, they are based on the concept of a template, of a model, and putting those two guys together. So in the template, you have placeholders, you have little strings that are meant to be finded and overridden with the data that comes from a model. React doesn't work like that. React asks you to provide complete descriptions of how you want to represent your UI. So you will not find any HTML stuff in React. And React is not a two-way binding library. So you don't have to expect, that's just for me because I came from Knockout. I was quite expert on Knockout. Then I stepped into React and I say, oh, damn, 0.5% of what it should do is missing here. And it was quite difficult for me the first day with React. And that's why we have to understand that React is not two-way, it's one way. It does one thing. It does this thing really, really well. But the other thing, you have to take care of it. And we'll see how. Yes, that's what React is and what React isn't. Then let's see some code. By the way, this presentation was built with React. I made it for this event tonight, and after pizza we will see how I build it. It's a React app that uses Firebase, and I have the remote here in the phone. It's the very same application that can drive another device. And I didn't dare to use it because I'm quite shy, but there is also a third application that you can use with the mobile device. Later we try it. It's meant for you to give me feedback. So we try it later. I didn't want feedback so far. As in every presentation, we start with an hello world. So this is the application that I've just built, that I've just run. It shows a simple string. We just try to see how this string came here into this screen. So let's move to the code. Do you read it? Better? Come on, tell me something. So React is a web application, so we are in a web page that is really, really simple. We have a div that is the target for us, for our application, is where stuff will be rendered. Then we load a library, React, it's just a library, and then we can write our application, which is just pure JavaScript. I've splitted our Hello World app in 3 layers that to me are the way to better understand how React works, is to think how a kitchen works. When we cook something, we start from a recipe. A recipe is a theoretical description of a food, a dish. Okay, is what you should do in order to get something to eat. And this is the first part. In React, it's called component. A description of what something should be served in a browser. Then when it's come to cooking, you need the ingredients. Okay, so you have this recipe that teaches you how to do Italian pasta or Italian pizza. Then you need the proper ingredients that you need to put together following the recipe in order to get the pizza. In React is data. So it's this little object in which we define what to show. We give the proper data to something. Okay, and we have an element. An element is where a recipe, a component, is coupled with some data, with its own ingredients. Eventually, we need somebody that takes the ingredients, takes the recipe, and cooks something. So we have the chef. It's React Render. React Render takes an element, so this recipe plus ingredients, and serve, and cook and serve this element to an application target, to the div that we see before. Okay, so the final application will be injected into this div, replacing whatever you have inside. So these are the 3 important steps in a React application. Description of what you need to show, data, what you really have to show, and where to show this stuff. Okay. This example is made on pure JavaScript. So a component, it uses a React API, which is create class. Okay, it will be a class in ECMAScript 6, and we define the main function, render, is the real core of React. Each component needs to explain how to show up, how to define what's the output of the component itself. So here we are taking another React API, so a title component of level 4, and we ask React to display this component with the text that it will be given to our component. Okay, so we take a native React component, a title, we feed him with a text that we will receive, and we serve it out as a render. This is a perfect fit for a theoretical description. A title plus a text do something. We are not really saying what to do with that. Okay, here we create an element. So we take the component that we just created, and we couple with a proper text. Okay, a string with a property name that we use inside a component. This stuff creates an instance of the class with the knowledge about its own data, but still is not doing anything. Is not working with the page. Eventually, the last React API that we see in this hello world, the render, takes this instance and it attaches the instance into the DOM. This is the important part. This API release an object, release a reference to a mounted element, to an element that has the knowledge of the DOM node with which it's dealing with. Okay, it's only after a render that you can do whatever stuff you want to do with the DOM that is involved in your application. Before this moment, there is completely no knowledge of the HTML of the page. What you use inside a React component are React components, React native components, or sub-components that you built. There is no HTML involved here. Okay. The second example, hello world example, it works exactly the same, but it uses a different approach for defining the component. Because all the usage of APIs to define components, create elements, it can grow pretty big. React ship a transformer, ship a little script that can understand something which is similar to HTML, which is a language that create instances of components. Okay, so when you want to use a native component, you just use its name as a tag, and you feed him with properties, with variables in curly brackets. This is just a syntax that React gives to you, completely optional. You are free to use it or not to use it. It's completely optional, and it's just to me a shortcut to defining components. Okay, create your own component, my app here. Then you can use this very component in another piece of JSX. But this is not HTML. One of the most straight things to say against JavaScript, against React. What I've said the first time I see this stuff is, what? HTML in JavaScript again? I mean, we left it a few years ago. We are coming back. Okay. I thought that it was really feeling bad to see this stuff. But then I come to an understanding that this is really not HTML. And I can't consider this to be a node anymore. Okay, just know this since the beginning, so you don't try to access this element within the render application. Okay, this is the hello world part. We have 15 minutes left before pizza. So let's see an example of an isomorphic application. I spent a few words before talking about isomorphic. So in this page, it's quite obvious. Let's run this one. It's quite obvious that our HTML, I mean the page itself, look, the body, what the body can be. The body can be as simple as a single empty div. Okay, it's just an empty div, and then a bunch of JavaScript. Of course, this script and this other should be coupled together in a bundle, so you have only one hit on the server to download the script. So then the body is empty, there is completely nothing. But when I render the application, there is an hello world. And as we said before, this hello world is invisible to Google. Okay, and this is a big problem. Is a lot of money that are wasted because of this fact for companies that put their business on Google optimization. So then let's try to see a different application. This is a little bit more complicated. It involves a little Node.js server, but let's make it working. Okay, hello world again. Nothing really changes. It's in a title now. So this application ran again an hello world application. Let's see the very source code of this application. It's a little bit more structured. So I've split the source code into many files. These many files are an hello world component. I'm using CommonJS here. So this piece of JavaScript is meant to be used by a compiler, by a bundler. In this case, is Browserify. Are you familiar with these names? You all know? Good. Okay, so this is just a component. Here I am defining my hello world component. Again, it returns a React element, a title level 1, and it gives in a text, which is a property of this component. That means that needs to be shipped to the component when the component is instantiated into an element. And also we define a user interaction. So we say that when the title component will receive a click, an event named click. Okay, this is not the native event. We will talk about this later. It should run one of its own method. The method is listed into the class, and okay, it's just an alert, not rocket science here. So this is only the recipe of our application, what the application should do, but we have no data and we don't know where to render the application. This is done in the app.js model. In the app.js module, we require our component and we create the element, the second level of the hello world that we saw before. So it is the recipe plus data, and we give it out to to whoever needs this stuff. Finally, we have the application client that requires the element again, and it renders the element into the DOM entry point of the application. So if we look at our HTML entry point, again we have a div app target, which can easily be an empty div that shows the hello world because the application render here. Okay, now I removed a thing, and this is a completely modern web application. That means that if I disable JavaScript, it doesn't work. Without JavaScript, it doesn't work. This is, of course, a JavaScript application doesn't work without JavaScript. Let's take a look again. I take back this placeholder, I reload it, and now it works, even without JavaScript. There is no JavaScript here. The application is visible. Why? Because it had been rendered on the server. The very same code that I just showed you, I just used a different chef. So instead to be served by the app client with the render, React render, I've run the very same element here with another React utility or APIs, render2string, which is just giving back the HTML which is represented by the application in the with the given data. Okay, and I can use a Browserify to just find and replace this template with mustache. So a little node application will render the app on the server and will inject the application here. Let's see the output of the page. There we go. I have my entry point, which is not empty anymore. It contains the full rendered application. Okay. What happens if I load JavaScript again? I just have the click. So without JavaScript, now let me take it out again. Without JavaScript, I still see everything, but if I click it, nothing happens. I enable JavaScript again, and then the very same application is responsive. React has rendered this application on the server. During the rendering, it will produce some attributes that are used again during the client-side rendering to check whether the description that you give the application, so what the application should show, is already shown into the HTML. If it's like that, React does nothing but adding the event handlers to the application. One of the most interesting consequences is that here, look, if I reload the page, there is no flickering. If I remove this placeholder, no matter how quick is your server, no matter how quick is your application, you will be able to see a flickering because you receive an empty page, and after a millisecond or even less, the hello world will be added. Okay, this flickering, so the application that completely render on the browser, is why we add the loading curtains to all our applications. Okay, I've added to the slideshow because it's not isomorphic. So isomorphic gives us all these benefits. So the application runs, or at least displays the information without JavaScript. So if you use a really old version of Internet Explorer, you still are able to see the application. It loads faster than a normal modern web application because it comes already rendered to the server. So if you load the classic, you load your CSS into the head. The CSS are already loaded when the browser will do the first render, and you just see what you have to see. There is no time wasted in creating anything. React doesn't discard the HTML. That's this is not coming. So why React is so fast? Because of this. When in a component you describe what you want the component to show, you output your component, give out a description, okay, a description of how to use some other components down to the native ones to represent your application. You don't create HTML, anything like that. You just create a description of other components. React take care of this description, take care when it's mounted after the render, take care of what's the HTML in the page. It creates a diff, and it applies only the differences between your description and what's already on the page. So even if I do, I don't know, a loop that render this hello world almost continuously in the page, nothing really happened in the DOM. That's why React is so fast compared to other libraries, because it never changes the DOM that is not meant to change. If the DOM is already in place, as you describe it, does nothing. In an isomorphic application, we exploit that because we don't write the HTML again. We just attach the event handlers.